Greetings to you. Welcome to Physics with Ben. Don't forget to subscribe and share this video to those that need it. In today's video, we want to plot the graph for the potentiometer experiment I did previously. Click in the description box to see the video link on the potentiometer experiment. So you guys were asking me, where is the graph? This is the video for the graph. You remember you saw something like this. Yeah, and this were the table of values we generated in the experiment. However, I did something new in today's video. I tried to increase another column, that is the V inverse column. Whenever you are preparing for any exams, you have to prepare in both ways, so that if the examiners will want to twist the question, you'll be able to stand your grounds. So what is here is simply what I want to explain with an equation. The meaning of these values you are seeing here, I will quickly explain this with an equation. Remember that a potentiometer is a variable resistor whose value is varied when the jockey is tapped gently across it. The equation controlling the whole of this experiment is simply the resistance of the wire is directly proportional to the length and inversely proportional to the area. Removing the sign of proportionality, will have R is equals to rho L all over A. It means that increase in the length will cause the resistance to increase. Increase, decrease, decrease. Then increase in the cross-sectional area will cause the resistance to decrease. However, call this equation number 1. From Ohm's law, you know that your V is equals to IR. So from here, we know that our R will be equals to our V all over I. So we are going to put the whole of this in here. If you do that, we are going to have something like this. So this implies that our V all over I is equals to rho L all over A. This is equation number 2, where V is the voltage in volts, PD in the circuit in volts, I is the current in ampere. This is the resistivity of the wire ohm per meter square, and this is the length of the wire. So if you remember very well, in the circuit diagram we have the current, and the I stands for the current. We have the voltmeter, and V stands for the voltmeter. We have PQ, and then the length L stands for PQ. So what is the meaning of this equation? So all the variables and the factors, they are all represented in this equation. It means that V and L have a direct relationship. It also means that increase in the length of the wire will cause the voltage to increase. Decrease in the length of the wire will cause the voltage to decrease. That is increase, decrease, decrease. How about length and current, I? It means that increase in the length of the wire will cause the current to decrease. So we have here increase, decrease, decrease, increase. It means that if you plot the graph of V against L or L against V, you are going to have something like this: 0, 0. The graph of V in volts against L in cm, or L in cm against V in volts, you're going to have something like this. Something like this, or something like this. And this will be your slope. So this is graph 1, graph 2, graph 3. So any of these will be the graph of L against V or V against L. However, if you plot the graph of L against I, you are going to have something like this: 0, 0. The graph of L in cm against I in amps, or I in amps against L in cm, you have something like this, a negative graph. Please take note of all this prediction. So what I'm trying to say is that anytime you are plotting a graph and you see table of values, you may screenshot this thing quickly. Very, very important. Anytime you are plotting a graph and you see table of values of this nature, for instance, we are to plot a graph of I against V. If you observe, I is increasing down while V is decreasing, meaning this graph, this against this, will give us this particular graph. Take notes. A graph of, this is my handwork, addition of this. A graph of I against V inverse will give you a straight line graph. It will give you any of this, either 1 or 2 or 3. Please take notes. Now, before we continue, let us take a look at the question quickly before we proceed. This is the question I used to do the potentiometer experiment. You may screenshot. You see, the asked to plot a graph of I against V. Lovely. So the next line of action is for us to take our scale, the scale of the graph. Good. Now this is a Waec standard graph. The graph you are going to be using on the day of experiments. So let us take the scale of the graph. If you observe these values very well, the highest value here on the I is the vertical axis. So let's write. On the vertical axis, the highest value is 0.48. That is the highest value on the vertical axis. So we are free to say that let's 4 cm to represent what? 4 cm to represent 0.1 units. And then on the x-axis, which is the axis for V, we can say that let's the same 4 cm to represent 0.5 units. What is the meaning of this graph language? Very simple. This is a Waec standard graph. The graph is segmented to 2 cm. 2 cm. That's the meaning of what you are seeing here. Lovely. Now, each 2 cm has 10 small boxes. 4 cm has 20 small boxes. So you are trying to say that in each 20 small boxes, you add 0.1. 0.1 plus 0.1 and so on and so forth. The other side too, the same thing this way. So we are going to draw this straight line here. I will call it the y-axis of the graph. Draw this line straight and then level it correctly as your I in amps. Then we are going to draw another one down here. Another one down here, straight to the from left to the right with an arrow here, and then you label this one as your V/boots. If you don't do this, what I just did, you're going to lose 1 full mark. This is half plus half, give 1 full mark. And then all physics graphs will always pass through the origin. So we write it 0, 0. Lovely. The next thing is to input the values here and then these values. So we said 4 cm to 0.1 unit. This is the meaning. So this is 4 cm. This is another 4 cm, another 4 cm, another 4 cm, another 4 cm. Can you see that? Good. So we have the first value here is 0.1. Another 4 cm, 0.1 plus 0.1, you have 0.2. You have 0.3. You have 0.4. Then you have 0.5. Can you see that? Good. The next thing we want to do is to add these other values from on the horizontal axis. We said 4 cm to 0.5 units. So this is 4 cm here. It's another 4 cm. It's another 4 cm. It's another 4 cm. So we have here as 0.5. 0.5 plus 0.5 will give you 1. So here is 1. So we have 0.5 times 3. Here is 1.5. So 0.5 times 4. Here is just 2. Good. That is it. So the next thing we are going to do, which is very, very important in plotting each graph in physics, is to find the value for each small box. Now that we have given scale at 4 cm to 0.1 units, what we're going to do right now is 0.1 divided by 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, up to 20. 4 small boxes will give you 4 cm means 20 small boxes. So we're going to say 0.1 divided by 20. So we say 0.1 divided by 20. That is, on the vertical axis, we say 0.1 divided by 20. And that will give us 0.005. It means the value for each small box here is 0.005. Now, on the horizontal axis, we say that 0.5 divided by 20, and that will give us 0.025. We have what? We have 0.025. 0.025. 0.025. So what we are going to do here right now is that we are going to divide everything here by 0.025. Everything here by 0.025. What we are going to do here again is that we're going to divide everything here by 0.005. When you do that, you are going to find the answer you are going to get stands for the number of small boxes you are going to count to get the exact figure, to get the exact value. So let us start this work. This is what I mean. Divide this by 0.025. Divide this by 0.05. Divide this by 0.05. Everything here by 0.05. So let's start with the first one. We have 0.36 divided by 0.05. 0.36 divided by 0.05. 0.36 divided by 0.005. Sorry, we have 72. It means that we are going to count 72 small boxes on the vertical axis before we are going to get this particular value here. Does it make sense? Yes, it does. So let's count. This is 10, 20, 30, 40, 50, 60, 70. This was 78, so we'll add 2 to use 71, 72. So this is where you locate this value on the graph. So here you write, this is just for writing simple. Don't do this in your examination hall, but just for clarification, this is 0.36. That's where the value is located on the graph. The next one is 1.35. 1.35 can be located by its exact value by dividing this by 0.025. So we say that 1.35 divided by this value here, which is also here, divide by 0.025. If you do that, you're going to have 54. It means that we're going to count 54 small boxes on the horizontal axis before we will get this exact value. So let's count. So this is the result. So this is 10, 20, 30, 40, 50. 1, 2, 3, 4. This is where your 54 is. So you bring this line, your 54. This is where your 1.35 is. So where this, put your ruler here. The ruler I'm using, the 30 cm transparent ruler, is the ruler you must use in all physics experiments. You'll see the reasons later. So put this line and then trace this line. Where this line where this line meets with the line coming from the horizontal line. Good. This is where they intersect. Where this line intersects, this is the point. That is a point. This line, and that is 1.35 and 0.36, they intersect at this point. So you plot it. Good. We plot the second value. 0.39. 0.39 divided by 0.005. Divide by 0.005. What do we have? We have 78. So we'll count 78 small boxes before we get this value. So let's count. This is 10. This is 10, 20, 30, 40, 50, 60, 70. Let's count 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is where you are going to locate 0.39. So our 0.39 is here. Let us locate this value quickly. We have 1.2 divided by 0.025. If we do that, we're going to have 48. So on this side, we'll count 48 small boxes before we're going to get 1.2. So let's count. This is 10, 20, 30, 40, 48. So 1, 2, 3, 4, 5, 6, 7, 8. This is 48. This is where your 1.2 is. So you put your ruler on that straight tiny line up so that you don't mix it up straight to where 48 is. Good. This is where they intersect. This is where they intersect. And then you draw that. You can see that the graph is already forming something like this. So we are going to repeat this for all of these values. So I just have to fast forward the video quickly. What I did for the first two values, what I did for the remaining values. The graph is this way, just as what I predicted. I told you you're going to have something like this. You can see that we're already having something like this. So that was a prediction. So this is your graph. You may screenshot it quickly. This is it. So this is how your graph will look like. So we draw our line of best fit. Taking that this is a negative graph. And so the reason why I was saying that you must not use an opaque ruler in your experiment is that when you are plotting your graph, it is expedient that you look through the points. Because sometimes some point may fall this side and the other point may fall on the other side of the line. So let's draw a line of best fit now. Just observe what I'm doing critically. This graph is one of the complex graphs to plot in physics. So let's go with, we have touched 3 points. This point, and this point. This one is falling on the other side of the line, and this on the other side of the line. So this is a very perfect graph. So let's go with something like this. Good. This is your graph. This is your graph. So we are going to draw our triangle. We will choose this point, and this point, and also this point. Your triangle needs to be big. When you have a big triangle in your graph, you minimize the error in your graph. So this is a triangle, and this is the other side. So this is change in V, and this is change in I. So the next thing we are going to do is you will trace this line, dot, 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 and then trace this one, dot, 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 dot. Trace this one down too, dot, 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 and then this also dot, 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 dot. So this particular point, this particular point is your V2. This particular point is your V1. This particular point, since this is a negative graph, we can say that this is your, okay, let's just write, this is your I1, and this point is your what? This point is your I2. Are you following? Good. So your slope is change in I divided by change in V. If you do that, that means your I2, in this case, it is a negative graph. It's gonna be, you know, in the positive graph, it is this minus this. But since it's negative graph, we're going to say this minus this. So in this case, we're going to say that I1, the I1 minus what? I2, because it's a negative graph. That one is a V2 minus V1. If you do that correctly, this is what you have. Your I1 is 0.1. Your I2, this value, how do you get this particular value here? Just say 0.05, sorry, 0.005 times 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So 109 times 109. That value is 0.545. So 0.1 minus 0.545 divided by, this value is somewhere here. How do you get the exact number? The line is somewhere here. So how do you get the exact value? Just say 0.025 times, let's count. This is 10, 20, 30, 40, 50, 60, 70, 80. This is 88. It's on 88 times 88. That will give you 2.2. So we have 2.2 minus this value here. Your V1 is somewhere here. Do you get? So 0.025 times 10, 20, 30. That is 30 times what? 30. That will give you 0.75. So this minus 0.75. If you do this correctly, your slope is 0.1 minus 0.545. That will give you minus 0.445 divided by 2.2 minus 0.75. If you do that correctly, you will having 1.45. So 0.445 divided by 1.45, that will give you minus 0.3069 minus 0.3069. You round it up. So your slope is what? AV. Yes. I against V. Your slope is what? A what? A slash V. Yeah, that is the value. So therefore, your slope is equal to this. So this is your slope. This is the graph you were asking me to plot. You may screenshot. So you can replicate this method I have taught you in plotting this graph in any graph in physics. With this method, you can plot any graph. This method of dividing everything by the number of small boxes, you can plot any graph. So let's quickly look at some of the questions they asked us here, and some of the questions I will not attempt to them. You have to check it in your textbook. Like because of the difficulty in this graph, I may skip the other question, but just look at it. What did the voltmeter measure? Trace that in your textbook and find everything there. What would be wrong with the connection if the ammeter deflects in the opposite direction? That is simply you have to change the polarity of the battery. If you observe that experiment, I have to change the polarity of the battery when the ammeter and the voltmeter deflected in the wrong direction. Now, state 2 advantages of using a potentiometer over a voltmeter for measuring potential difference. Click in the description box and watch that video. You see everything there. However, one of them is this. The potentiometer measures EMF precisely and accurately. There's no zero error. However, the voltmeter measures EMF with a zero error because of the pointer. So the voltmeter you have is zero error. Number 2, the potentiometer can measure currents can measure EMF when there's no current in the circuit. But for the voltmeter, there must be current in the circuit before you measure the EMF. So they ask us to state 2 precautions. Yeah, state 2 precautions. I hope this is all. Yeah, the precautions in this experiment are simple. 1, you ensure tight connection. So report, I ensure tight connection during the experiment. Number 2, you are making use of the voltmeter and the ammeter. The voltmeter and the ammeter, you made use of the 2 guys, and also the potentiometer. So what will you say? I avoided error due to parallax when taking reading on the voltmeter, ammeter, and also the potentiometer. To this, I believe we have come to the end of this video. Please, I want you to use this pattern and help me plot the graph of I against V inverse. The slope of the graph, I'll give you a hint, is simply power. You know, power P is defined as IV. So the slope of the graph is the power generated in the circuit. So Waec may come this way. Please do this and tag me in your comment box. Tag me in your comment as you are commenting in the comment box, so that I can know if you are actually improving in your experimental skills in physics, watching the videos on my channel. To this, we have come to the end of today's video. Don't forget to subscribe and share this content to those that need it. I wish you A's in all your external examinations in physics. God bless you. Bye-bye.